Hey everyone, how you doing? Mr. Graham here. Welcome to take 7 of trying to do this video correctly. I just want to send this video out before we started our unit next week. This is the introduction to magnets and how do they work. It's an old joke from like 2005 for all of y'all. So, the simplest definition of magnetism is that it is the power to attract. Things that magnets can attract, such as that fluid in the really cool GIF, which hopefully we'll take a look at on Monday if it comes in the mail. They're all called magnetic materials. So nails, paper clips, scissors, anything that a magnet can attract, that's a magnetic material. And side note, magnets are themselves magnetic material. But not all magnets are shaped just like specific clumps of metal. The two most common shapes we're going to be dealing with throughout all of class is what's called the bar magnet, which you can see on the left because it's a bar, and the horseshoe magnet, which is the one cartoons use, which is on the right. Every single magnet, regardless of shape, has a north and a south pole. You see it listed on that bar magnet. It is not listed on the horseshoe magnet, but the ones we use in class, they'll have the markings. This is how compasses work. If I were to take that bar magnet, if I were to hang it from the ceiling on a string and allow it to rotate, the north part of the magnet, called the north seeking or just the north pole, would point in the direction of the north pole. And that's how people navigated 600 years ago. Oh, how far we've come. Surrounding the magnet is the space where the magnet will affect magnetic materials. This is called the magnetic field. We can draw this using lines, yet if we were to be super realistic and accurate in the magnetic fields, we would have to draw an infinite number of lines. So for sake of argument, we draw this many. Science had to choose, when we were developing the science of magnetism, what direction the magnetic field was supposed to go. So for no other reason than this is the way it's done, the magnetic field starts in the North Pole and originates there, moves out in an arc, those are the different arcs listed, all the way to the South Pole, and it ends there. So it starts in the north and moves in the path to the South Pole. That's just how we've decided to define it. Regardless of shape, this is true. So we looked at the bar magnet before, but here's the horseshoe magnet. You can see the magnetic field lines starting in the North Pole, traveling out from there in different arc patterns and ending at the South Pole and stopping there. Now here's a question that I want you to ponder. How strong do you think the magnetic field is on the left side of this image? So where you would hold this magnet, how strong do you think that magnetic field is? Just a few seconds, just think about it. Now, if you said that there is no field on that side where you would hold it, you would be correct. If I were to hold it from the north and south poles and try to magnetize something, it wouldn't work because there's no magnetic field there, because as you move away from the center of the strength of the magnetic field, which as you can see, the more lines that come together, the stronger it is. As you move away from that, the magnetic field gets weaker. So, couple last things I want to go over before we start on Monday is these two simple principles when it comes to magnets. Like attracts the unlike, or opposite poles attract. As you can see in these GIFs, which are way too fast, you can see the north and the south want to get together, and then you can see the like repels like, which is north and north want to push each other, and south want to push each other. So there's a great analogy we'll get into in class, just to give you a hint. It's about boys and girls in two separate boats. It's hilarious, it's stupid, and I can't wait to talk about it. So yeah, that's it. See you guys in class on Monday. If you have any questions, feel free to write them down. If they're pressing, you can email me. But bring questions to class. We'll talk over them, and we'll start our unit. Thanks, guys.